Assalamu alaikum. This is section 3 using chemical formula. It's very easy. All what you want to know that if you have any formula like NaOH, you just count the mass number from the periodic table. You will have it in the exam. The sodium has 23, oxygen 16, and the hydrogen is 1. So if you add them together, you will have 40, right? Okay. So if you put beside the number AMU, atomic mass unit, so you are talking about the formula mass. This is the formula, and this is the formula mass. Formula mass. So if I ask you about the formula mass of sodium hydroxide, you will count the mass number, and then you put AMU, atomic mass unit, beside. If you put beside the number gram, so this is the molar mass. So this means that the mole of the sodium hydroxide is 40 gram per mole. Okay? Also, we need to know that number of moles in any sample he gave you, number of moles equal mass over molar mass. So if I ask you about the mass of a sample, I will show you example. You multiply the number of moles times the molar mass, and the molar mass you can count it yourself because you have the periodic table and you can get the mass number. And also we know that any mole contain Avogadro's number of atoms or molecules, right? So this means that the mass of any substance, if any sample, equal the the number of molecules equal number of moles multiplied by Avogadro's number. Na means Avogadro's number. Yani for example, NaOH is 40 gram per mole. So if I ask you what is the number of molecules in the 40 grams, this is Avogadro's number because this is the molar mass. If I give you 80 gram, so 80 gram means 2 moles. They are 2 moles. So multiply by Avogadro's number, so it will be, if Avogadro's number is 6 times 10 to the power of 23, it will be 12 times 10 to the power of 23. Okay, so let us revise what is the meaning of the mole. The mole concept. What does this mean? Listen, if I go to the supermarket to buy 1 kilogram of rice, so how much is the 1 kilogram? Let us say 5 real. Okay. So how many rice grains there are in the 1 kilogram? Yeah, approximately 5,000. So if you have 5,000 grains, their price is 5 real. So what if I wanted to buy only 1 rice grain? So you will multiply, you will divide 5 by 5,000. Okay, so it will be something very, very, very small. Yani we don't have a currency. It is too small to deal with. This is why we cannot buy the rice by grain. What if I want to buy 1 sugar crystal? It is the price is too small to deal with. We don't have such a currency. What if I want to buy 1 milliliter, one drop of milk? If you have 2 liters of milk and their price is like 5 or 6 real. So what if you want 1 drop? The seller will not give you this quantity because it is too small. How much you will pay? A fraction of halala? We don't have it. We don't have this currency. So what is the solution here? The solution is we can't sell the rice by grain. We can't sell the sugar by crystal. We can't sell the milk by drops. We buy it by kilogram or by liter because this is the minimum amount that it has a considerable value. Exactly the atom. If we want to deal with the atom, the mass of one atom, it will be extremely small. It is something times 10 to the power of negative 27 kilogram, for example. From where you can get the balance that can weigh this extremely small amount. So this is why also when we deal with atom, we deal with a certain number of atom. The mass of this number of atom is whatever, like a dozen, as if I have a dozen of atom, and the mass of one dozen is whatever. So this dozen in chemistry is the Avogadro's number, Ma, Avogadro's number, which is equal to, it is 6.023 times 10 to the power of 23 atoms, if you are talking about monoatomic molecule, or molecules. Fine. Approximately 6 in the problem, if you make it 6 times 10 to the power of 23, we also can consider it right. Okay, so how the mole of any substance contains this number of atoms or molecule. The mass of this number is considerable enough to be deal with. Type. How to measure the mole? The mole is mass number expressed in gram. For example, when I give you H2O, from the periodic table you have in the exam, the mass number of the hydrogen is 1, and we have 2 hydrogen atom, and the oxygen is 16. So 1 times 2, 2 plus 16 equal 18 gram per mole. Means that if you weigh 18 grams of water, which this is a mass, you can measure it, so it includes this number of water molecules. I gave you sodium hydroxide before, calcium carbonate, calculate the mole. You will have this kind of questions in the exam. I give you the formula and you measure the molar mass. So calcium is approximately 40, the mass number. Carbon is 12 and oxygen is 16. So the molar mass will be 40 plus 12 plus 16 multiply 3, because we have a 3 oxygen here. 16 multiply 3. So this is 48, 50, 60, and 40 equal 100 gram per mole. If I give you sulfuric acid, for example, H2SO4, okay, calculate the molar mass. So again, hydrogen is 1, sulfur is 32, and oxygen is 16. So it is 1 times 2, 2 hydrogen plus 32, 1 sulfur plus 16 times 4. This is 46 plus 32 plus 2, يعني 34, it is 98 gram per mole. Gram per mole. Okay. Okay, so what is the difference between these numbers, the 18 gram and the 100 gram and the 98 gram? All of them contain the same number of molecules. If you take 18 gram of hydrogen, of water, 18 gram of water, they contain Avogadro's number. 100 gram of calcium carbonate contain Avogadro's number. 98 gram of sulfuric acid contain Avogadro's number. So the mole of any substance contain Avogadro's number of molecules or atoms. So why they are different masses, although they contain the same number of molecules? Because the mass of each molecule is different. Like when you have a dozen of lemon and a dozen of watermelon. Both of them contain 12 pieces. But the mass of dozen of lemon is different from the mass of dozen of watermelon, simply because the mass of each watermelon is different from or bigger than the mass of one lemon. Okay? Percent composition the percent of anything equal its value divided by the total. So percent composition means the percent of the element divided by the total, or the mass of an element divided by the total mass of the formula. For example, lithium sulfate, LiSO4. Lithium is monovalent and sulfate is divalent, okay? So we put, this is -2 and this is +1, as you know. So we put the valency of the second under the first, and the valency of the first under the second, so it is Li2SO4. This is the formula. And I wanted to measure the percent composition of each element, the lithium, the sulfur, and the oxygen. Okay, so first of all, I measure the total mass of the formula, the molar mass. So from the periodic table, lithium, this is lithium sulfate, Li2SO4. Lithium is approximately 7, sulfur is 32, and oxygen is 16. So the molar mass equal 7 multiply 2 plus 32 plus 16 times 4. Okay, let us count this. 64 and 32 and 14, it is 110 gram per mole. Okay, so the percentage of lithium, listen to this. When I say this is a mole of lithium sulfate, by the way, this formula can indicate the molecule, يعني the molecule of lithium sulfate contain 2 atoms of lithium, 1 atom of sulfur, and 4 atoms of oxygen. And also I can say that 1 mole of lithium sulfate contains 2 moles of lithium and 1 mole of sulfur and 4 moles of oxygen. So the percentage of lithium, how many moles we have? 2. So they are 7 multiply 2. This is the mass of this element divided by the total mass of the formula, and you get the number in percentage. 12% multiply 100. Okay, so it will be 12%. Okay, percent of sulfur equal, we have 1 mole of sulfur in the formula, يبقى 32 divided by the total, so it will be 29%. Okay, and percent of oxygen, you have 2 ways. So either you add this and you subtract from 100 because from 110, because the total formula is 110, right? خلاص? So you add 29 and the 12 and subtract from 100, or you can calculate it as you did with the sulfur and lithium. So I say it is 16 times 4, 46 divided by 110 equal 58%. Okay? I'm sorry, if you don't subtract from 110, you subtract from 100. I'm so sorry, because the total percentage is 100. Okay, so if you add this, 2 plus 9, 11, 2 plus 9, 11 plus 8, يعني maybe there are some fractions, it is okay. You can approximate, يعني, لكن, so this will be 9, and this will be, are we sure from this number? So if we add them together, so yes, if you add them together, so it will be 99, يعني approximately 100, and this means that there are some fractions. No problem if you يعني approximate it in your solution. Okay? Okay, now we can take more practice about this. If you open your textbook, page, let us say, 239. What is the molar mass of barium nitrate? This is the question. Barium nitrate. So first of all, I will put the formula. Barium comes first, and then nitrate. And we memorize that nitrate is monovalent anion, so all it has a charge of -1. Barium is +2, so this means that we cross the valency like this, and the one we don't write it, so it is barium nitrate all 2. So he wants the molar mass. So from the periodic table, the barium is 137.33 gram per mole. Okay, so we can make it 137. No problem if you approximate. Equal 137 gram per mole. And here, pay attention that the bracket is multiplied by 2 as subscript, so you will multiply each element in the bracket by 2. So nitrogen is 14, multiply by 2, so they are around 28. Nitrogen, approximately 28 gram. And here oxygen, oxygen 16. We have a 3 oxygen multiplied by 2, so it will be 6. So the oxygen is 16 multiply 6, so they are 96, I believe, right? Gram, because we have 6 mole of oxygen here. And then you add them together, so the whole formula total equal 137 plus, I'm sorry for this, type, plus 28. Okay, no problem. So you add them together, and this is the molar mass of the formula. Okay, this is very easy. Okay. In page 240, you have this question. What is the mass in grams of 2.5 moles of oxygen gas? 2.5 moles of oxygen, what is their mass? Okay, so we will apply the triangle I gave you in the beginning. Okay. Problem. Okay. Number of moles equal mass over molar mass. So he gave me the number of moles. The molar mass, I can get it. This is oxygen. Oxygen 16 multiplied 2, so it is 32 gram per mole. This is the molar mass. So I can get the mass. So the mass equal number of moles, 2.5, multiply the molar mass of the oxygen, 32. From where I got it, again, the mass number is 16 multiplied 2, so it is 32. Okay, and the answer, you will have it in gram. Okay, it is 80. Okay. What is the percent, the practice in page 243? Find the percentage composition of copper 1 sulfide. Yes, copper 1 sulfide. He wants the percent composition in copper 1 sulfide. Copper 1 sulfide means the valency of the copper here is 1. And the sulfur group 16, so the charge is -2. -2 here, 1 means this is 1 and this is 2. So we write it like this, Cu 2, I think the battery, Cu2S. Okay, no problem. So back to the periodic table, we will see that the copper is 63.5. Okay. Copper, the percent of the copper equal the mass of the element we have here. 2 moles means 63.55 multiplied by 2 divided by the total. The total is 63.55 multiplied by 2 plus 32. 63.55. What's wrong? Okay, fine, no problem. So I will make it oral. So it is, first of all, we get the total formula. We multiply the copper by 2, 63 by 2, and we add the 32, which is S. And then we get each element alone. 63 by 2 divided by the total. This is the percentage of the copper. You can get the percentage of sulfur by 2 ways, either by subtracting the percent of copper from 100, or you make 32, here 1 sulfur mole, divided by the total. Okay, thank you so much. This is, I think, if you understand this, so we are done with number 3, with section 3. Okay, thank you.